Hello students, welcome to physics class. In last class, we are discussing about the third chapter of first basic physics, that is a motion in a straight line. And in this chapter, we studied about speed and velocity. And today we will see first what are the differences between speed and velocity. In examinations ಕೇಳ್ತಾರೆ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ಬಿಟ್ವೀನ್ ಸ್ಪೀಡ್ ಆ್ಯಂಡ್ ವೆಲಾಸಿಟಿ, ಸ್ಪೀಡ್ ಮತ್ತು ವೆಲಾಸಿಟಿಗೆ ಇರುವಂಥ ವ್ಯತ್ಯಾಸಗಳೇನು ಅಂತ ಕೇಳ್ತಾರೆ. ಲೆಟ್ಸ್ ಸಿ ವಾಟ್ ಆರ್ ದ ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ಸ್ಪೀಡ್ ಆ್ಯಂಡ್ ವೆಲಾಸಿಟಿ. ದ ಸ್ಪೀಡ್ ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ ಎ rate of change of position of a body in a unit time without considering the directions. Okay? And velocity is rate of change of displacement of a body with the time. And speed is a scalar quantity, velocity is a vector quantity, and speed is always positive, velocity may be a positive, may be a negative, or it may be a zero. Velocity positive ಆಗಿರ್ಬೋದು, negative ಕೂಡ ಆಗಿರ್ಬೋದು. Okay, because it is the directions, it is depend upon directions. The displacement is negative, velocity also negative, and displacement is zero, velocity also zero. First we'll see what is accelerations. When we can say one body is accelerating if its velocity is changing with the time. ಒಂದು ಬಾಡಿ ನಾವು ಯಾವಾಗ ಆಕ್ಸಿಲೇಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದರ ವೇಗವನ್ನು ಅದು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು, ಆರ್ ಸಪೋಸ್ ಅದರ ವೇಗವನ್ನು ಕಡಿಮೆ ಮಾಡ್ತಾ ಹೋದರೆ ಕೂಡ ಬಾಡಿಯನ್ನು ಆಕ್ಸಿಲೇಟ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ. ದ ಟೈಮ್ ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಎ ಮೂವಿಂಗ್ ಬಾಡಿ ಇಸ್ ಕಾಲ್ಡ್ accelerations. And acceleration is denoted by a small letter a, and it is given by an expression accelerations is equal to change in velocity divided by time. It is the ratio of change in velocity divided by time. It is a rate of change of velocity with time is giving accelerations, and its dimensions is m0 l1 t minus 2, because this is a dimension of velocity divided by dimension of time. Based on this, m0 l1 t minus 2. Unit is SI unit is meter per second square, or meter second to the power minus 2. And when a body is said to be accelerated, and acceleration may be a positive or acceleration may be a negative, suppose velocity decreases with respect to time, then acceleration is getting negative. That acceleration is called retardation anta kuda heltave. And sometimes suppose body is moving a constant velocity, there will be no change in velocity, both magnitude as well as directions, then acceleration is said to be zero also. So that in acceleration also we have a different type of accelerations. What are the different type of accelerations? Let us see, given in a syllabus. See, when you can say body is said to be uniformly accelerated. Okay? Uniform acceleration is ಏನು? If the rate of change of velocities, both its magnitude as well as direction of change in velocity is remain constant, then body is said to be uniformly accelerating. Or the change in velocities both in magnitude as well as directions is remain same, then its acceleration is said to be uniform. For example, one ball is falling under a gravity, steadily falling under a gravity, ಆಗ ಆ ಬಾಲ್ ನಾವು ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಬಟ್ ಆಕ್ಸಿಲೇಷನ್ ಯಾವುದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ದಟ್ ಆಕ್ಸಿಲೇಷನ್ ಯು ನೋ ದಟ್ ಜಿ ಆಕ್ಸಿಲೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಅಂತ ಹೇಳ್ತಾರೆ, ಇಟ್ ಇಸ್ ಎ 9.8 meter per second. Like that we can give some another example. Suppose one car is moving, its a velocity is increases from 2 meter per second to 4 meter per second. Next time seconds it is increased to 6 meter per second. Next time interval it is increased to 8 meter per second. But if we calculate it as a change in velocity, In every 1 second, the velocity is increases by 2 meter per second square and such a way that its acceleration is remain constant. Then the body is moving in a uniform accelerations. They are saying it is moving in a uniform accelerations. Next, non-uniform acceleration. When body is said to have a non-uniform accelerations, if magnitude and directions or both of acceleration is going on changing with respect to time, then body is said to have a non-uniform acceleration. Suppose the rate of change of velocity is changing with respect to time, or direction of its velocity changes with time, then body is said to have a non-uniform accelerations. For example, I have a body which is changing its velocity from 2 meter per second to 4 meter per second in 1 second. Next time interval it changes to 8 meter per second in another second. Next time interval it may increase to some 10 meter per second in 1 second. Like that, the change in velocity, magnitude of change in velocity is going on changing, then body is said to have a non-uniform accelerations. Similarly, we have a average accelerations. What is the meaning of average accelerations? What is a total change in velocity in a particular interval of time divided by the total time taken. That ratio is giving average accelerations. Therefore, average acceleration means it is a ratio of change in velocity divided by time interval, and that is giving average accelerations. Similarly, we have a instantaneous acceleration. Suppose one moving body is changing its velocity, that rate of change of velocity in a particular instant of time, rate of change of velocity in a particular instant of time is called its instantaneous acceleration. These are the different type of accelerations for a moving body. Next, we have a position time graph. For a moving body, how to draw a position time graph? A graph is drawn by taking position of the body along a y-axis and time along a x-axis is called position time graph. A graph obtained by plotting position of a body along y-axis and time along x-axis, that graph obtained is called position time graph. Using this position time graph, where it is helpful to explain or describe the nature of motions. Okay. For example, if you draw a slope for this particular graph, the graph is on the slope, it is giving velocity of a moving body. By that we can determine velocity of a body using position time graph. And also the position time graph for a different type of motions is asking for examination. Let us see position time graph for a different cases. For example, one body is at rest. If a body remains in a state of rest, how position time graph? Okay, if you plot a graph along y-axis which represent positions and x-axis is represent time. With respect to this time axis, bodies remains in that same position. Because of that reason, they are getting a straight line parallel to time axis. A straight line parallel to time axis. This is a position time graph for a body which is at a state of rest. Similarly, position time graph for a body moving in a uniform or constant velocity. How we will draw a position time graph for a body is moving in a constant velocity. There is, as in figure, there is a position time graph. Here position of body is changing, but the rate of change of position is remain constant because body is moving in a uniform velocity. Because of that reason, it is a straight line inclined with a time axis. It is a straight line inclined with a time axis, such a way that the slope of the graph is remain constant throughout its motions, such a way that we can say body is moving in a constant or uniform velocity. Time graph for a increasing velocity or accelerating body. Okay. For a body which is accelerating, its velocity is going on increases, then position time graph is shown as a curve, it is an exponential curve with a positive slope, and that is represent a position time graph for a body moving in a increasing velocity. Similarly, what is the position time graph for a body is moving in a decreasing velocity? Suppose one body is moving in such a way that velocity decreases with respect to time, then accelerations or slope of this velocity, that velocity decreases with respect to time, then the graph curve is like this. Okay, slope is decreases with respect to time, then I can say velocity decreases with respect to time. So graph represent position time graph for a body moving in a decreasing velocity. We have a velocity time graph. A graph plotted by taking velocity of a moving particle along y-axis and time along x-axis is called velocity time graph. ಒಂದು ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡೋದು ಹೇಗೆ ಅಂತಂದರೆ ಇಲ್ಲಿ ವೆಲಾಸಿಟಿಯನ್ನು y-axis ಅಲ್ಲಿ ತಗೊಳ್ಳೋದು, ಟೈಮ್ ಅನ್ನು x-axis ಅಲ್ಲಿ ತಗೊಂಡು we are obtain a graph for a moving particle. That graph is called velocity time graph ಅಂತ ಹೇಳ್ತೇವೆ. Using this velocity time graph, we can determine distance traveled or displacement. We can determine its acceleration. The slope of this velocity time graph always represent accelerations. Then area under this velocity time graph in a particular time interval, it is giving displacement or distance traveled. Okay. Let us see velocity time graph for a different cases. We can draw velocity time graph for a moving particles. For example, first the velocity time graph for a body is moving in a constant velocity. On the body it is moving a constant velocity, then what is the velocity time graph? Again here velocity is taking along y-axis and time along x-axis. Since velocities remain constant with respect to time, we are getting a straight line parallel to time axis. This is a velocity time graph for a body is moving in a constant velocity. Next, what is the velocity time graph for a body is moving in a uniform accelerations, but it start from origin. Okay, when the body is there, it start from origin, then its velocity increases in a uniform rate. Then what is the velocity time graph? The graph is shown as in figure. It is a straight line inclined with an x-axis, and this is a velocity time graph for a body start from origin and uniformly accelerating. Next, we will see velocity time graph for a body which is uniformly retarding or velocity decreases uniformly with respect to time. Then the graph is as shown in figure. It is a straight line again inclined to the y-axis, that is represent velocity time graph for a body which is uniformly retarding. Similarly, next we will see velocity time graph for a body which is moving like that, velocity is increasing with respect to time, or you can say it is a increasing accelerations. Okay, then the graph is a curve like that, the acceleration is going on increases, like that slope of graph is increases. Similarly, we will see velocity time graph for a body which is have a decreasing acceleration. A moving particle with a velocity is changing such a way that acceleration is decreases with respect to time, then graph is a curve, and like that the slope of this graph is going on decreases with respect to time. Like that we can give the velocity time graph for a body which is thrown into space. Okay, the example ಕೇಳ್ತಾರೆ, draw a velocity time graph for a different situations for a moving object. That suppose a body is thrown into space such a way that its velocity is going on decreases. When it is reaches a maximum height, its velocity becomes 0. Then after that it is increases as it is reaches the ground, it is come back to same velocity, initial velocity. and such a way that velocity diagram is shown in figure. Let's see what are the uses of this velocity time graph. This is a 2-mark question is asking, write the uses of velocity time graph in the calculator. The velocity time graph is used to find the nature of motions. Second, it is used to determine the velocity of a body at any instant of time. Third, to determine the displacement or distance travelled by a body during a particular time interval. Fourth, to determine aggregation of a moving body. Using this velocity time graph, we can come to know about nature of motions. ಯಾವ ರೀತಿ ಬಾಡಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ based on the shape of this velocity time graph we can come to know. Second, using this velocity time graph at any instant of time we can determine its velocity. ಮುಂದೆ ಆ ಗ್ರಾಫ್ ಅನ್ನು ಎಕ್ಸ್ಟೆನ್ಷನ್ ಮಾಡಿಕೊಂಡು ಯಾವುದೇ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಅದರ ವೆಲಾಸಿಟಿ ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ನಾವು estimate ಮಾಡಬಹುದು. Third is using this velocity time graph, the area under this velocity time graph use distance traveled. ಒಂದು ರಾಕೆಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಅದರ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ನಮಗೆ ಗೊತ್ತಿದೆ ಅಂತಾದರೆ ಅದು ಎಷ್ಟು ಟೈಮ್ ಇಂಟರ್ವಲ್ ಎಷ್ಟು ದೂರವನ್ನು ಕ್ರಮಿಸ್ತದೆ ಅಂತ ಬೇಸ್ಡ್ ಆನ್ ಏರಿಯಾ ಅಂಡರ್ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ವಿ ಕ್ಯಾನ್ estimate. That is another uses. The acceleration of moving body at any instant we can estimate using velocity time graph. These are the uses or application of velocity time graph. We have one question to show that area under velocity time graph is equal to displacement. That prove ಮಾಡಲಿಕ್ಕೆ ಕೊಡ್ತಾರೆ exam as a 3-mark questions. Let us see how to prove this area under velocity time graph is equal to displacement. Consider a body which is moving in a uniform velocity. Okay. Other velocity time graph is shown in figure. Okay. Since body is moving in uniform velocity, velocity time graph is a straight line parallel to time axis as in figure. Now I want to estimate what is the distance travelled or displacement of a body at a particular interval of time t seconds. Okay. Now how to determine the distance travelled or displacement? According to this, area under velocity time graph gives the displacement. First we will find out what is the area under this graph or displacement. We have to calculate. For that we have to calculate area under this velocity time graph. And the shaded portions shows that area under this graph, and that rectangular is base t and height is v0. Then you know that area of this rectangular, area of a rectangular is equal to base into height. ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಬೇಸ್ ಇಂಟು ಅದರ ಉದ್ದ ಮತ್ತು ಅಗಲ, ಇದನ್ನು ಗುಣಿಸಿದರೆ ನಮಗೆ ಅದರ ವಿಸ್ತೀರ್ಣ ಸಿಗುತ್ತೆ. ಏರಿಯಾ ಆಫ್ ದಿ graph rectangle will get. That area under this velocity time graph that is equal to area under the area of this rectangle, that is base into height, that is equal to v0 into t. Okay, v0 is velocity and t is a time. And let us write this equation is equation 1. Next, according to definitions, what is a velocity? For a uniform velocity is equal to displacement divided by time. Okay, the equation shows that v0 is equal to displacement, that is x, divided by time interval t. Okay. Now by rearranging these equations, we'll get the displacement x is equal to v0 into t. Okay. Therefore displacement x is equal to v0 into t. Write equation 2. From equation 1 and 2, it is found that the right hand side of equations of equation 1 and 2 are equal. Therefore left hand side of equation also is equal. That means area A is equal to displacement x. From this we can come to know that area under velocity time graph is equal to displacement or distance x. Okay. This is one of the question they are asking to prove that area under velocity time graph is equal to displacement.